Hello everyone, welcome to the Luminous Science. Today we are going to discuss about the topic nucleophilic substitution reaction. So before going into the definition, let us see what does a nucleophile mean. A nucleophile is an atom or a molecule or ion that donates a pair of electrons to form a new chemical bond. By the name itself only, we can know that nucleophile, which is nothing but nucleus loving. And because of this nature, they are attracted to a positively charged or electron deficient atom, usually a carbon atom. So, the name nucleophile itself suggests philic is nothing but loving. So, nucleophiles are those atoms, ions, or molecule which are attracted by the positive or the electron deficient atom. So here now let us see what does a nucleophilic substitution reaction mean. A nucleophilic substitution at saturated carbon atom. When a nucleophile replaces any one of the atom of a compound, it is called as nucleophilic substitution reaction. So here if we consider a saturated carbon compound, now what does a saturated compound mean? So saturated organic compound are the compound in which all the carbon-carbon bond are single covalent bond. They contain the maximum number of possible hydrogen atom attached to the carbon atom. They contain only single bond. So from the name itself saturated, we can know that the carbon atom which contains only single bond, and most of the atoms which are attached to carbon will be usually hydrogen. So nucleophilic substitution reaction is one such reaction where one or more number of atoms which are attached to the saturated carbon atom in a compound are replaced by a nucleophile. Such reactions are called as nucleophilic substitution reaction. And if the compound is saturated, then it is a nucleophilic substitution reaction of a saturated compound. Since we are considering a saturated carbon compound or saturated carbon, the name can be also called as nucleophilic substitution reaction of a saturated compound. Now, alkyl halides undergo mainly two types of reaction. So, alkyl halides as we know, when any alkane has an halide group, they are called as alkyl halide. They undergo mainly two types of reaction, that is nucleophilic substitution reaction, then comes elimination reaction. So nucleophilic substitution means the substitution of one of the atom which is attached to the carbon are replaced by the nucleophile. And then comes elimination reaction. Here from a saturated carbon compound or organic compound, one of the substituted atom will be removed, and thus the corresponding product of organic compound or even the carbon compound may gain double bond or triple bond. So they become unsaturated in nature. So what is unsaturated carbon compound or atom is? They are the organic compound that contain at least one carbon-carbon double bond or one carbon-carbon triple bond. So because of these multiple bond, they do not contain the maximum possibilities of hydrogen atom. So here saturated refers to single bond and unsaturated refers to double bond or triple bond. So those conversion from saturation to unsaturation can be seen in the course of elimination reaction. Now, based on the nature of the alkyl halide, the nucleophilic substitution reaction takes place by two mechanisms. If there is any kind of reaction going, there should be a process or step-by-step reduction or substitution or substitution or oxidation of any of the corresponding compounds obtained in the each step, and the representation of each step is called as mechanism. So usually the nucleophilic substitution reaction takes place in two ways or in two mechanisms, that is SN1 mechanism and SN2 mechanism. Here SN1 stands for unimolecular nucleophilic substitution reaction, and SN2 mechanism is also called as dinucleophilic substitution reaction. So now let us see what does SN2 mechanism mean. So to understand this, we'll consider an example, that is hydrolysis of methyl chloride. So when methyl chloride is heated with aqueous KOH solution, methyl alcohol is formed. When methyl chloride is heated with aqueous KOH, methyl alcohol is formed. So here is the corresponding reaction. Methyl chloride, when it is reacted with aqueous KOH, it leads to the formation of methyl alcohol plus KCl. This is the byproduct. Now let us see the mechanism. The mechanism involves only one step. It is only a one-step reaction. This is a single-step reaction. Hence, this is the rate determining step. So now we can see the mechanism when methyl chloride So the methyl chloride and the aqueous KOH, the OH minus from KOH will attack the carbon from the opposite side of the halide present and leads to the formation of transition state. So here there is a partial bond which are represented by a long dotted line. This means they are in the transition state. And finally, we'll get methyl alcohol and Cl minus as a byproduct, which then reacts with the K and leads to the formation of KCl. So this was our byproduct initially, which we have seen here. Now let us see the description. The rate of the reaction depends only on the concentration of both nucleophile as well as the alkyl halide. Hence, it is a second order reaction. Since the rate of the reaction, and also we know that it is a single step reaction, and thus here concentration of both the nucleophile and alkyl halide plays an important role. Since there are two reagents involved in the rate determining step, this is a second order reaction. And in SN2 reaction, OH minus attacks the carbon atom from the opposite side of the chlorine present. So the OH minus always attacks the carbon atom from the opposite side of the presence of the halide. Because that carbon containing the halogen does not have any bulky group attached to it. Hence, the order of the reactivity of alkyl halide is usually methyl is more faster than primary, which is faster than secondary, which is faster than tertiary carbon atoms. So, if any carbon atom contains a halogen, it means that the carbon atom may not contain any other bulky group. Since there are no bulky group present in the opposite side of the halide atom present, usually the attack of nucleophile always takes place in the opposite side of the halide molecule present. Now, let us see SN1 mechanism. So to understand SN1 mechanism, we'll take an example of hydrolysis of tertiary butyl bromide. So we are considering a tertiary butyl bromide hydrolysis. When tertiary butyl bromide is heated with aqueous KOH, it leads to the formation of tertiary butyl alcohol. Though we are considering same reagent, but the starting material we are considering is different. Since we are dealing with the two different mechanisms, that is SN1 and SN2, to understand them, we take these examples so that we can easily understand the concept. Now, as mentioned in the reaction description, when tertiary butyl bromide is reacting with aqueous KOH, it leads to the formation of tertiary butyl alcohol plus KBr, which is a byproduct. The reaction is similar, but the mechanism they go through is entirely different. Let us see them. So the mechanism, SN1 reaction is a first order reaction. The rate of the reaction depends only on the concentration of the alkyl halide and independent of the nucleophile which is present. So in SN1 mechanism, since it is a two-step reaction and the rate determining step contains only the tertiary butyl bromide, that is the alkyl halide. Thus, the rate of the reaction is only dependent on the concentration of alkyl halide and not on the concentration of the nucleophile which is present. Now let us see the reaction mechanism which is involved. Here the reaction mechanism includes two steps. The first step is tertiary butyl bromide will undergo the process called as ionization to form a tertiary butyl carbocation. So here we can see the tertiary butyl bromide will undergo a process called as ionization, which is nothing but formation of ions. So here we'll get a positive ion and a negative ion. This is called as tertiary butyl carbocation and this is the bromide ion. So this is the slow step and also the rate determining step. Now step 2 includes the nucleophile OH minus will attack the positively charged carbon from any side to form the product tertiary butyl bromide. So, since OH has a negative charge on it, it can easily attack the positive charge which is present on the carbon atom of tertiary butyl carbocation and leads to the formation of tertiary butanol. So, this is thus SN1 is a two-step reaction and it is a first order reaction. So this was about a simple SN1 and SN2 reaction. We'll see into more SN1 and SN2 reactions and what other synthesis or reactions, named reactions involve SN1, SN2 reactions in our further session when we take up those topics. Now let us see another interesting topic of aromatic electrophilic substitution reaction. Since now we have been dealing with the alkyl halides or alkyl compounds. Now let us see how the substitution reactions are usually seen in the aromatic compounds. We know that aromatic are nothing but usually the compounds which obeys the Huckel's rule, that is, they must contain 4n plus 2 pi electrons, usually benzene or any kind of cyclic compound which obeys the Huckel rule. Now let us see how does the electrophilic substitution reactions occur and are seen in aromatic compound. The reaction in which hydrogen atom of the aromatic ring is replaced by an electrophile are called as aromatic electrophilic substitution reaction. So before dealing with the definition of this, first let us know what is an electrophile mean. An electrophile is an atom, an ion or a molecule that will accept a pair of electron to form a new chemical bond. The name literally means electron loving. Because of this, electrophiles are attracted by the electron rich species. Since we know the aromatic compound are usually electron rich species, so they can easily donate their electron to an electrophilic molecules or atoms, and electrophiles are those which can attract those electrons and form a new bond. So by understanding both the definition of aromatic and electrophile, let us understand the substitution reaction. Here, in aromatic electrophilic substitution reaction, the hydrogen atom which is present in the aromatic ring is replaced by an electrophile. So, when hydrogen is replaced by an electrophile, a new chemical bond is formed, and they are called as, the process is called as aromatic electrophilic substitution reaction. Let us see an example. When benzene undergoes electrophilic substitution reaction, the benzene ring with its delocalized pi electron is an electron-rich system. As we know, the benzene obeys the Huckel rule, which has 6 pi electron, that is 4n plus 2 pi electron. So these electrons are used in delocalization, and it is attacked by a electrophile, giving rise to a substituted product. Here, if we see, there is one of the hydrogen atom. We know there are all hydrogen atom, but for the sake of example, we'll consider one hydrogen atom here. When this one hydrogen atom is substituted by an electrophile, we are generalizing the reaction, hence written as ENU. Here we can see E plus is an electrophile and NU is represented as a nucleophile. So when an electrophile is replaced in the place of a hydrogen atom of an aromatic system, it leads to a new compound formation, or a new chemical bond is formed between the carbon atom of the aromatic compound and the electrophile which was present. This is called as aromatic electrophilic substitution reaction. Hope you all like this video. If you have liked this video, kindly subscribe to the Luminous Science. Thank you for watching. See you all in my next video.